Hello, my name is Jason Huggins, and today I'm going to talk about some of the updates to Uniface regarding security and performance. I will start by illustrating the need for security. I will show what we have done in Uniface, and for the second part of this presentation I will talk about some of the improvements we've made to the core of Uniface. So let's look at network security. Security is a big challenge to our industry. Our main communication mechanism for many years has been TCP. However, TCP is inherently insecure. None of the layers of the TCP protocol have inbuilt security. Many threats therefore exist to this inherent weakness. In this day and age, data privacy is absolutely essential. The result of these insecurities have led to many data breaches. From just 10 years ago, we used to see breaches of tens of millions of records. These days we're in the billions of rows per year. The average cost of a data breach to organizations is in the range of $4 million. In the US alone, identity theft cost the economy $16 billion in 2014. It is all of our responsibilities to ensure we bring these numbers down with our IT solutions. What I'm showing here is a typical solution deployment. It could consist of a web interface, a desktop interface, mobile, or just API calls into the solution. Where the communication is over TCP alone, we have a risk. The TCP channels are all potential weak points. These channels therefore expose the data to potential inappropriate interception or modification. The solution is therefore to augment the TCP protocol with a security layer. A popular choice is the transport layer security protocol. This is a set of cryptographic protocols that secure the communication. It is a successor to the secure socket layer SSL, given it is more secure and more efficient. In Uniface, we have therefore created an OpenSSL layer on top of our TCP stack and created our TLS driver. We utilized the OpenSSL libraries to provide the TLS functionality. OpenSSL is very comprehensive in the field of cryptography. It's backed by major organizations and government institutions, is well maintained and supported, and particularly important for Uniface, has extensive platform coverage. Configuration of OpenSSL in Uniface is very straightforward. It follows the regular driver approach. Instead of saying TCP : for your network communication, you'll now say TLS : The connection paths look very similar to the TCP paths. We also have the complementary setting, uses TLS params, in which you can provide the parameters to configure the TLS driver. This can include things such as the certificates you are using or the pre-shared key passwords. Given the client may be connecting to multiple destinations, each with its own TLS configuration, it is possible to specify multiple profile in the net settings section. So, given the addition of this OpenSSL layer, we now go to a secure deployment. The TLS driver currently encompasses network traffic including client and server processes, whether exclusive or shared, the WRD, post messaging, and debugger communication. Coming next is uRouter monitor communication, UPOP mail, LDAP, and future requirements as they emerge. There are things to consider when using TLS. Development practices will remain more or less the same. It may be necessary to consider transaction sizes and the amount of client versus server processing given encryption adds an overhead. From a deployment point of view, it will be important to understand security and encryption, particularly which policies are required within your business. The policies may include things such as which encryption protocols to use. It is also important to secure the configuration information of TLS using Path Scrambler. Please note that the Path Scrambler has a new encryption mode, and this must be used in the case of TLS to ensure maximum security. Let's now look at some of the changes to the core of Uniface. The key efforts to the core of Uniface have focused around currency and refactoring. These efforts have been conducted against all supported platforms and have focused on the kernel of Uniface, which is written in C and C++. We have updated the C compilers and the operating systems upon which we compile Uniface. This extends beyond Uniface. We've had to look at all of the dependencies and update those appropriately also. We have updated our coding techniques and existing code to ensure maximum performance and security. In updating the currency, we've ensured to fix all breaking changes, and as a guiding principle, we've ensured to future-proof as much as possible. This process has been a large project involving 5.5 man-years of effort. We have updated the C compiler across all platforms. However, for the purpose of this presentation, I will just look at the Visual C compiler. We have upgraded from Visual C++ 2005 to Visual C++ 2015. There have been many changes, as can be seen in the document on screen. There have been a number of breaking changes that we've had to address, and as you can see, this document is very long. Here are a few examples of things that have been fixed and refactored. For those technically familiar with Visual C++, there is no more double casting. In basic terms, this can lead to confusion and corruption, and also makes it very difficult for the compiler to make appropriate recommendations. We have also made many 64-bit enhancements to ensure type safety and data integrity. Another interesting enhancement was around floating point precision. In short, floating point calculations are not actually precise. We find that the algorithms used to manipulate floating point values vary in their accuracy. Distinct changes could be observed between the different versions of the Visual C++ compiler. To ensure consistency in Uniface and maintain future-proofing, we've converted much of our floating point arithmetic to integer arithmetic. By updating our compilers, we've ensured we can benefit from ongoing fixes. There have been many fixes to date, however, the older compilers are now going out of support and no longer receive these fixes. Performance was another important aspect of this project. Performance improvements were achieved from two angles. Firstly, through the efficiency of the new compilers and dependent libraries, and also through the refactoring of the code that we applied to Uniface. Internally, we have seen improvements of up to 20% in the performance of our Uniface applications, specifically the IDE in this case. It is important, however, to note that every application is different, so your results may differ from ours. As an experiment, I've run my own performance tests. Some of you will recognize this profiling visualizer that we use to look at the profile output of Uniface. What I've done here is test the performance of the profiling tool itself. Here we see the result of running against 9704, which used the Visual C++ 2005 compiler. And here we see the results of exactly the same test run against Uniface 10, which is compiled using Visual C++ 2015. In summary, the test had approximately 500,000 4GL statements, 100,000 DBMS actions, and 100,000 3GL calls. In this case, I saw an improvement of approximately 30 seconds, which equates to a performance improvement of 23%. As I say, each application is different, so you will see different results. Thank you for listening.